Hey guys, the objective of this video is just to run through a couple of Mohr circle examples. So here we have a soil element with principal stresses acting on it. So we know our major principal stress and the minor principal stress. And we're interested in finding what the stresses are on a 30-degree plane. So what the stresses would be if the element was rotated 30 degrees. So first step, actually before I start, I should stress that for the graphical procedure, it is highly recommended that you have the following things in order to ensure that your answer is as accurate as possible. You should use graph paper. You should have a compass. And should also use a protractor. So let's start the question. So if I plot our plane of normal stress against shear stress, and we know our principal stresses, which are 40 and 20. So if I was to do this to scale, roughly to scale, so 10, 20, 30, 40, and I'll mark on the plane where the principal stresses are. So sigma 1 and sigma 3. So now the center can be calculated by the average of the two principal stresses. So 40 plus 20 divided by 2. That gives us 30. So this is where the center of the Mohr circle is. And the radius can similarly be calculated by sigma 1 minus sigma 3 divided by 2. And that gives us a radius of 10. So now we know what the center is and we know what the radius is. We can draw the Mohr circle. So obviously when you do this on paper, it's going to look a lot neater. So next step is to determine the pole. So we look at our element. Sigma 1 is acting horizontally. So we can go back to the Mohr circle and locate sigma 1. And if we draw a line acting parallel to the plane through which sigma 1 acts, so that's just a horizontal line here, the pole will be found at this point here, which is where sigma 3 is. And now we're interested in what the stresses are at an angle of 30 degrees above the horizontal. So what you need to do is, from the pole, measure an angle of 30 degrees and project a line from the pole. And this line that intersects with the Mohr circle, you'll then determine what this value for normal stress and shear stress is. And if you've drawn it to scale, it should give you a value of 35 for the normal stress and 8 for the shear stress. So in this next example, we have an element on an inclined plane of 30 degrees. And we also have normal stresses and shear stresses acting on this element. And because we have shear stresses, that indicates that these normal stresses are not the principal stresses. So this question is asking us to find the principal stresses and principal planes for this element. So now, firstly, I'll just write down 2 points based on these stresses, which we can then plot on our normal stress versus shear stress plane. So I'll call point A 100 and negative 25, and point B 40 and positive 25. Now I'll just plot these points on the chart. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Make sure you're drawing this to scale as well, guys. And the other point, 40 and 25. So 10, 20, 30, 40, 10, 20, 25. Now what's interesting to note is that because these normal stresses are acting perpendicularly, this actually means that they're on opposite ends of the Mohr circle. Recall from a couple of videos back where I talked about that circle geometry property. So essentially, whatever the angle is in real life, it gets doubled in the Mohr circle when you measure from the center. So knowing this, we can then connect these 2 points of a straight line. And this here is our center of the circle, which is 70 and 0. That's our point. Sorry. And using a compass, you can then measure the radius and draw the Mohr circle. So reading off the chart, we can determine that the principal stresses sigma 1 and sigma 3, they work out to be roughly 109 and 31. And in order to... Now we're also interested in determining what the principal plane is. So if we go back to our example, this plane here corresponds to this line here. So now what we need to do is determine the angle between this line and the principal plane, which is this horizontal axis. So this angle here is 2 theta. And if you've drawn this to scale, you can just measure what this angle is using a protractor. And this works out to be 40 degrees. So therefore, theta equals 20 degrees. So if we go back to our original example, the principal plane is basically found by rotating anti-clockwise by another 20 degrees, like so. So you'd have sigma 1 acting like that, and sigma 3 acting that way. And while we're at it, we might as well find the pole for this Mohr circle as well. So if we look at this normal stress here, 40, which is acting on this plane, which is 30 degrees above the horizontal. If we go to our Mohr circle, so this is point B here. Let's project the horizontal from point B. Now using a protractor, measure off 30 degrees from this point and see where this line intersects with the Mohr circle, which is approximately this point here. And this will be your pole. You could also determine the angle which this normal force here, 100, what this angle makes with the horizontal. And you could measure that from this point here, A. And that should take you to the same place for the pole. That's it for today's video. Hope this helps, guys.